Hello friends, today we are going to discuss about inverting amplifier. Inverting amplifier. Inverting amplifier is the basic application of op-amp. It is named as inverting amplifier because the phase difference between the input and output is 180 degree. Let us see the circuit diagram. First let me draw the op-amp. This is the inverting input terminal, inverting input terminal and non-inverting input terminal. The input voltage is connected through the resistance Ri to the inverting input terminal, and the feedback resistance Rf is connected between the input and output. Non-inverting input terminal is connected to the ground. Now let us mark various parameters. Vi is the input voltage, Ri is the input resistance, Rf is the feedback resistance, V out is the output voltage, I1 is the input II is the input current, IF is the feedback current, and this node as A, voltage at this node is termed as VA. Now let us try to find out the relationship between the input and output voltage. At node A, apply Kirchhoff's current law. Kirchhoff's current law. We know that the Kirchhoff's current law states that the algebraic sum of currents at a node is equal to 0. Before applying KCL, assume ideal op-amp. Ideal op-amp. We have studied the characteristics of ideal op-amp. The ideal op-amp is having the characteristics of infinite input impedance. So, which means that the current flowing through this op-amp input terminal is equal to 0. So now only two currents are there coming to node A. One is coming from the input signal Vi, another one is flowing through the feedback resistance. So by applying Kirchhoff's current law, II plus If is equal to 0. So Ia is equal to the voltage difference in voltage across the resistance divided by the resistance value, that is Va minus Vi divided by Ri plus If, feedback current. Voltage difference is Va minus V out divided by Rf plus the op-amp current is 0, is equal to 0. Okay. Now the ideal op-amp is going to draw no current, that we have already seen. Now the voltage at A, node A is equal to 0. The node A is at virtual ground. Node A is at virtual ground. Therefore, Va is equal to 0, which implies, if you substitute in expression number 1 implies minus Vi by Ri plus minus V out by Rf is equal to 0. Therefore, V out by Rf is equal to minus Vi by Ri. We want to find out the output voltage V0. V0 is equal to Rf by Ri that is minus Rf by Ra into Vi. So this is the expression for output voltage. This is the expression for output voltage. If you want to find out the gain of the amplifier, gain is this part, the multiplier, which is equal to minus Rf by Ri. Here the minus sign indicates it is inverting. This is for inverting amplifier. This is magnitude of gain. Gain magnitude. So let us quickly recollect what we have studied now. We have started discussing about inverting amplifier. The input is connected to the inverting input terminal through the input resistance Ri. Feedback resistance Rf is connected between the input side and output side of the op amp. At node A, we apply Kirchhoff's current law. Kirchhoff's current law states that algebraic sum of currents at a junction is equal to 0. We assume that it is an ideal op amp, so the current drawn by the op amp is 0. So at node A, II plus If is equal to 0. Writing the expression for II and If, that is Va minus Vi by Ri plus Va minus Vout by Rf is equal to 0. Since node A is at virtual ground, Va is equal to 0. Therefore, simplifying, we get the expression as Vout is equal to minus Rf by Ri into Vi. The gain formula is minus Rf by Ri. In this, the minus represents it is inverting. The base difference between the input and output is 180 degree, and Rf by Ri is the gain magnitude. Hope you have understood this concept. Thank you all. We will meet in the next video.